Let us start our sixth part of compile design. Here we are going to discuss about type checking. The compiler has to do semantic check in addition to the syntactic check. What is the semantic check? Static done during the compilation, dynamic checking during the runtime. A type checking is one of the static checking operations. We may not do all type checking at the compile time. Sometimes we use to dynamic checking also for the compiler. Okay. So a type checking is a collection of rules for assigning type expression to the parts of the program. What is a type checker? Type checker implements a type system. A sound type system will eliminate runtime checking by the type errors. A program language is strongly typed. Every program is compiled, accept, execute without any type error. Type expression, a type of language construct type expression. Type X can be basic type. So all the primitive data types such as integer, real, character, boolean. So type error to signal to the type error. Void, no type data type. So type name. The name can be used to denote a type expression. A type constructor applies to the other type expression. Arrays is a type expression. Then array is a type expression where it denotes index range of starting to ending is integer. Products, it is similarly type expression, and the Cartesian product P1 and P2 is a type expression. The integer and integer, the product will result will be integer. Pointer, if t is a type expression, then pointer of t is a type expression. Example, pointer of integer. Functions, we may treat function as a programming language as mapping from a random domain D to a range type R. So the type of the function can be denoted by the type expression D implies R. A simple type system. Procedure, declaration of the expressions, declaration D, declarations are first basic type, the integer P. So what it does, this data type, what is ID entry type will be data type that will be added to the T. So character, integer, real, pointer, array. So array of integer number of T1. T type equal to array of integer number, value, what is the value equal, what is the type, integer and integer. Okay, similarly the type system will be decided. The type system expressions. E implies ID. E type equal lookup ID entry. What is the ID type? The type will be copied into E. Character literal. What is the character? The positive E type. Integer literal. Integer will be positive E type. Real literal. The real value positive E type. E implies E1 plus E2. So what is the type of E1 and what is the type of E2? Both will be compatibility, but same type will be assigned to E. E modulus of E type equal to integer and E1 type equal to array of structure of T, then E type equal to E type equal to T. Else E type will be error. Similarly, pointer, E type equal to pointer, then E type equal to T. Otherwise, it will be error. This is a type checking expressions. Type checking statement. If statement ID equal to expression, the ID type equal to E dot type, E dot type, ID type equal to E dot type, then S type equal to void. Else, S type equal to error. S type applies if E then S1. If E type equal to boolean, then S will be followed the same time. Otherwise, else S type will be error. Do one. While E do S1. If E type equal to boolean, then else, then S type equal to same. Else S type equal to type error. Type checking functions. E implies E1 of E2 means E2 type equal to S, the E1 type equal to S implies T, then E type equal to T, else E type equal to type error. Integer double X character 1. The floating point double X character integer character integer. Okay. So R1 type is a data type. Structure equals type. So how do we know that two type expressions are equal? As long as type expressions are built from basic type, we may use structure equals between the two data types. If S and T are the same basic type, then return true value. Else, if S equal to array of S1 number is 2, and T equal to array of T1 and T2, the return type will be structure equal to S1 and T1 and the structure equal to S1 and T2. Similarly, class number S1 and S1 and S2, T1 and T2, the return type will be structure equal to S1 T1 and structure equal to S2 T2. S equal to pointer of S1, T equal to pointer of T1, the return equal to structure equal to S1 of S1 comma T1. Similarly, else return false. It's a structure equal to algorithm. Names of type expression. In some programming language, we give a name to type expression and we use the name as a type expression afterwards. Type link point will be the same data. Variable p comma q is a link will be followed. Variable r comma s link to the cell. Okay. How do we treat the type names? Get equivalent data type expression for this data type. Then use a structured equivalent. Treat the type name as a basic type. So cycles in type expression. Type name, type link equal to pointer of cell. Type cell equal to record. X equal to z, next equal to link, and so on. So we cannot use a structure equivalent if there are cycles in type expression. We have to treat type names as a basic type, but this means that the type expression link is different than the type expression sum. Okay. So it's a cycles in type expression. Two conversions, x plus y. What is the type of this expression? Integer or double? Both will be added. So what kind of code we have to produce if the type x equal to double and the type y equal to integer? So integer to real, y to t1, real plus t1 equal to x of t2. Which is the internal conversion of one type to other type. Thank you for listening.